Let's go over the bell ringer. If you guys saw that there was a bell ringer question as you guys came in, I'm going to hopefully do that every time we have a live meeting. That way it gives you guys a chance to be thinking about chemistry while we wait for everybody to show up. So that way we're not just sitting here staring at one another or me staring at the blank screens of you guys for 5 minutes waiting for you guys all to show up. The bell ringer says, identify the number of protons, neutrons, and electrons of the following elements: aluminum, potassium, and tungsten. Did you guys find the protons, neutrons, and electrons of those three things? Did anybody find any of those things for any of the three elements? Did anybody find the protons for aluminum? Maybe you want to throw it in the chat if you don't want to say it out loud.
$13.
13, perfect. Did anybody find the number of electrons of aluminum? Perfect. 13 protons, 13 electrons. How many neutrons are in aluminum?
14.
14, perfect. We took our mass number of 26.98. We rounded that number to a whole number, and since it's 26.9, it's going to be 27. And then we do our 27 minus our protons, which was 13, to get our number of neutrons, which was 14. What about potassium? Did anybody find the number of protons in potassium?
Isn't it 19 protons?
It is 19 protons. Perfect. How many electrons are in potassium then?
Nineteen.
19 protons and 19 electrons. Perfect. And the last one for potassium, how many neutrons are there?
20.
20. Perfect. 19 protons, 19 electrons, and 20 neutrons, because our mass number was 39. And so we took 39 minus 19 to get our 20. Tungsten. This one was farther down in that periodic table. Tungsten. How many protons are there for tungsten?
$74 protons.
74 protons. Perfect. A lot more than our 19 from before. How many electrons is tungsten going to have?
74.
74. Perfect. The same number of protons and electrons, because we want them to cancel out and add up to 0, because we subtract them. And then the last one, what about our neutrons? How many neutrons is tungsten going to have?
110.
Perfect, 110, because our mass number for tungsten is 183.8. So when we round that to a whole number, it's 184. And if we subtract our 184 minus our 74 protons, we'll get our number of neutrons, which gives us 110. Perfect. Before we go ahead and go to our activity for today, which is the Lewis dot structures and Bohr models, so we're going to be getting into something new. Before we do that, I do want to go over that formative that you guys took on Friday. So that's Zoom, that's not my, all right. So formative 1.1, it was just finding the Bohr models or drawing the Bohr models of each of these elements. So the first one was lithium, and most people at least understood how to find the number of protons, neutrons, and electrons. So I'm just going to go through and say the number of protons was 3, the number of neutrons was 4, and the number of electrons was 3. When we did that, we first have to draw our nucleus in the center. So everyone had this. We had 3 protons. We had 4 neutrons. Might have tried to draw that a little too small. Let me make it a little bigger for everybody so everybody can see it. Protons equals 3, neutrons equal 4. That's all I need you to see in my nucleus. Remembering that the nucleus and the first orbital are going to be different, so we have to draw another ring to draw our first orbital. And how many electrons can I put in that first orbital? Do you guys remember? How about we look at it a different way? In that first row, how many different types of atoms do I have in this first row?
2.
2. So how many electrons can I put in my first orbital?
2.
2. So that means our third electron is going to go in a new orbital. So our first 2 electrons are going to go in this first orbital. And our electrons are just little dots. And our third electron is going to go in the next orbital. So then we draw our entire lithium atom, and then we're good. The next one was where it got a little trickier for a lot of people. This is the biggest mistake one that I saw, just because chlorine is something we hadn't gone through as a whole class yet. So I wanted to see how you guys did with this one. This one was our challenge question. Out of all of them, I think this one was the challenge. If we look, this chlorine has 17 protons. It has 18 neutrons, and it has 17 electrons. So the first thing we do, most people are doing great with this. We draw our nucleus. We label our protons with 17. Our neutrons was 18. Now, our first orbital, how many electrons could go in that one again? How many?
2.
2 electrons can go in here. Only 2, because once we fill up our 2, if we look at our periodic table, once we get to 2, that row is complete, and we can no longer put more electrons in that first orbital because that first row is gone. So now our second row, how many electrons can we put in that second orbital? If we look at that second row, how many electrons do you think we can put in there?
8.
We can only put 8 electrons into that second row. So when we draw this one, we're going to make our second orbital. Oops, switching back to pen. Second orbital, and we're going to draw 8 electrons in there. So I'm going to put my 8, 1, 2, 3, 4, 5, 6, 7, 8. How many electrons do I have total right now?
10.
I have 10 total right now. And how many are we supposed to have?
17.
17, which means, what do you guys think we're going to do to get to that 17?
Outer orbit.
Add another orbital. Perfect. Add that outer orbital. And how many are we going to put on that one?
7.
7. Perfect. Careful, not 8, because we already had 10. So we only want 17 here. So we only want to add 7 more to get to our 17 total. But yes, we can put up to 8 electrons on that orbital if we had 8. So this is what I looked for when I was looking for chlorine. Remember, this was the hardest one, I think, for most people when we were looking. The next one made it a little easier again, beryllium. The protons for beryllium were 4. The neutrons for beryllium were 5. And the electrons for beryllium were 4. We drew our nucleus, and we had our protons was 4, and our neutrons was 5. And then we drew our first orbital, and we drew 2 electrons in there. And then our second orbital, and we drew 2 more. Carbon has 6 protons, 6 neutrons, and 6 electrons. So carbon wasn't too bad either. We drew our nucleus with our protons and neutrons. We put 6 of each in our nucleus. We drew our first orbital and put 2 electrons in that first orbital. That orbital's full, so we got to add a second orbital. And we added 4 more electrons, adding up to our total of 6 electrons. We had nitrogen. Nitrogen has 7 protons, 7 neutrons, and 7 electrons. So again, just like carbon and beryllium, we have protons and neutrons in our nucleus, 7 of each. Drew our first orbital and added 2 electrons. Once that orbital was done, we added a second orbital and added 5 more electrons. And then our last one was neon. Neon, there were 10 protons, 10 neutrons, and 10 electrons. So when we drew this one, we put our protons and neutrons in the middle, 10 of each. And then we drew our first orbital and added 2 electrons, and our second orbital and added 8 electrons, for a total of 10 electrons. Are there any questions on any of these 6 problems? All right, then I want everybody to open up their Bohr models and Lewis dot practice. Everyone open this one up, and I want you guys to come up with the Bohr model for magnesium. Okay, so on your own, come up with the Bohr model for magnesium. So just do A, excuse me, only do A right now. So I'll go back to the periodic table in case you don't have yours out and ready to go. And just come up with that Bohr model for magnesium. I'll give you guys about a minute and a half to do this. Remember, if you have any questions, you can always send me a chat individually, or you can always ask in front of the whole class. All right, just about 15 more seconds to try and come up with that Bohr model for magnesium. All right, so I'm gonna go back. Oops, I'm gonna go back to my thing. All right, so let's first, can anybody tell me how many protons magnesium is going to have?
12.
12.
Perfect. How many neutrons does magnesium have?
12.
Perfect. And how many electrons does magnesium have?
12.
Awesome. All right, so now that we have our protons, neutrons, electrons, somebody tell me the first thing we do.
Draw your nucleus.
Perfect. So we're going to draw our nucleus. There we go. And what goes in the nucleus?
Protons and neutrons.
Protons and neutrons. So we have 12 protons, and we have 12 neutrons. All right, what's next?
Draw the orbit. Or
Perfect. I draw my first orbital, and how many electrons can go there?
2.
2 electrons. So I put my 2 electrons, then I can draw my second orbital. How many can go there? How many electrons do I put in my second orbital?
8.
8.
Perfect. So I'm going to put my 8 on there. Am I done, or do I need more electrons?
Need 2 more electrons on another outer circle.
Another outer shell, and we're going to add 2 more electrons. Oh, that one looks nice. All right, so now we have all of our protons, neutrons, and electrons. Is everybody okay with our Bohr model? Because now we're going to do a couple more things. All right, before we get to that Lewis dot structure, I do want to talk about a couple things. There's a specific name for this outer shell. So our outer shell, or outer orbital, has a specific name. I have to spell outer. So that specific name is going to be our valence shell. And the electrons that go on it are going to be called our valence electrons. And these electrons are probably the most important electrons on any atom, just because in later terms, we're going to figure out that they actually make the compounds. So they're the reason that compounds can be formed, or so that we can have different compounds, just like water and all those other good things. So for right now, we're just going to know that these outer electrons are called valence electrons, and they're the most important. So what I want to do now is, before we can get all the way to the Lewis dot structure, I want us to look at this. I'm actually going to draw it again right here. Protons was 12, neutrons was 12. We have 1 orbital, 2 orbitals, and then our 3rd orbital. All right, so now that we have our, I redrew it just so we could have it again, so I didn't have to erase things on the first one. What we're going to do in order to draw our Lewis dot structures, there's a lot of, it's going to be a lot simpler than our Bohr model, because the only thing the Lewis dot structure cares about are those valence electrons. So what's going to happen is I'm going to get rid of that first, my second orbital shell, and my first orbital shell, and my nucleus. I'm going to get rid of everything there. All I want to see are my valence electrons. Once I have how many valence electrons I know, then what I do is, in the middle, I'm going to take and I'm going to write the element symbol. Do you guys remember what the element symbol is for magnesium?
Mg.
Mg. So capital M, lowercase g. And the last thing I'm going to do is I'm going to get rid of the orbital itself. All I want to see are those valence electrons. So I'm going to move them closer. So this is how we create our Lewis dot structure. Our Lewis dot structure is going to be, I'm going to change colors so we can see what I'm writing. All right, our Lewis dot structure is going to be our element symbol. So, oh, no, yeah. So our element symbol goes in the middle. And then around our element symbol, we're going to draw the valence electrons. So how many valence electrons does magnesium have?
2.
Only 2 valence electrons. So that's all we need to draw here. So if we look, it says for part C, and this is the only time I'm going to ask this, what did you include in the Bohr model that was not included in our Lewis dot structure? So can anybody tell me something that was in the Bohr model that's not in our Lewis dot structure?
The valence shell.
The valence shell is in both. Okay. Oh, so not the circle, so not the orbital. So the valence shell wasn't there. Perfect. Just the valence electrons are in both. What else? What else do we see in our Bohr model that's not in our Lewis dot structure?
Protons and neutron.
The protons, the neutrons. Is there anything else we see in our Bohr model that's not in our Lewis dot structure? There should be one more thing we see. Let's look at our Lewis dot structure. What besides the element symbol do we see on that Lewis dot structure? What are these called again?
Electrons.
What kind of electrons?
Valence electrons.
The valence electrons. Are the only electrons on this one the valence electrons? Or do we have
No.
other electrons on there?
They're electrons.
We have other electrons. So all of the electrons are on the Bohr model. And only the valence electrons are on the Lewis dot structure.
Ew.
What's that? Once you've got all this down, I want you to go ahead and try and draw the Bohr model for potassium. I'll give you guys another 2 minutes to do that one. So draw potassium's Bohr model. Who can tell me how many protons there are in potassium?
19.
19, perfect. How many neutrons are there in potassium?
20.
20. And how many electrons are there in potassium?
19.
19, awesome. All right, so now what do we draw first?
Protons and electrons. Neutrons.
All right, so we have 19 protons and 20 neutrons. And then how many orbitals do we need here?
Two.
We only need 2, okay. Cool. So I put how many electrons in the first orbital?
2.
2 electrons, perfect. How many electrons can go in that second orbital?
8.
8, awesome. All right, do I have all my electrons or do I need more?
You need more.
Awesome. Okay, so I have to have a third orbital. All right, how many electrons can go in my third orbital?
9.
Careful, 9 can't go in there. Did somebody say a different number?
8.
8, because if we look at that periodic table again, we have 8 in our third row, so only 8 electrons can go in that third orbital. Oh, so I'll put 8 on there again. Do we have 19 electrons yet?
No.
No, so we have to add another orbital. We have a fourth orbital. And we're going to add how many electrons to that one?
1.
1, perfect. All right. Are there any questions about this Bohr model? All right, then I want to ask a new question. How many valence electrons does potassium have? Remember, valence electrons means the electrons in the outer orbital.
1.
Just 1, perfect. There's only 1 valence electron. And then none of the rest of them need to be drawn. And what is our element symbol?
K.
K for potassium, perfect. So when we draw this, we're going to draw our K for potassium, and then we're just going to put 1 valence electron next to potassium, and that's it. We're done.